Good day and welcome to Draft Survey webinar. We are Marine Learning Club and my name is Artur Sokolov. Before we start, let's check the communication. How do you read me? Please put the marks from 1 to 10. How do you read me? Is the connection fine for our webinar? The connection is fine. I can see the marks 10, so that means we can start. I will remind you about some of our rules. First of all, don't keep silent. Please write the comments, write the questions in the webinar room, and I will try to answer on your questions. If you have some interesting experience related to draft survey calculations, draft survey process, please write this experience in the comments and we will discuss it. Let's share with the knowledge and let's share with the experience. I would like to remind you that we are not the organization who employ the crew. We are not the crewing agency. We are Marine Learning Club who give the knowledge and share the experience. Therefore, please don't write the comments related to the job search or related to your business. Let's be professional and let's write the comments only related to the educational purpose, to the draft survey calculations. Let me introduce myself. My name is Artur Sokolov. I'm active master mariner, and my courses were completed by more than 1,000 participants. I'm author of the books like Ship Stability, Complete Edition, Draft Survey, Complete Edition, Oil and Chemical Cargoes Calculations. I'm the author of multiple video courses like Draft Survey Advanced Course, Ships Handling Course, Preparation for Chief Officer Interview, Ballast Water Management and Treatment Systems course. And I have been working in the maritime education for the last 6 years. And generally, we have created a lot of educational courses that let the possibility for our colleagues to rise their competence and get the promotion thanks to the knowledge and competence. What are my goals for today? I will introduce Marine Learning Club. I will explain why do we need to know the draft survey calculations. We will discuss top important questions from the draft survey, and I will offer the best terms for participating in the course Advanced Draft Survey course. What is Marine Learning Club? We are the training club for seafarers. There are not so many places in the world who can give the practical knowledge and share the experience that is required for us, for seafarers to gain the next position, to gain the required knowledge and competence to pass the interview. This knowledge will let you the possibility to approach to the captain and tell that you're ready for the next position and ask for the interview and subsequently to get the promotion. We have been developing maritime educational courses for the last 6 years. We started with the Ukrainian audience, and our courses in Russian language for Ukrainian audience were attended by more than 10,000 maritime professionals, and these courses gave the possibility for the promotion based on the knowledge and competence. We are all active seafarers, so we explain in our courses only the practical things that are actually needed for the successful work on board. We share the knowledge and experience with the participants, and we share only the needed and practical concentrated knowledge. What is our goal? Our goal is promotion based on knowledge rather than time. Why do we need to know draft survey calculations? Draft survey is essential knowledge and important competence for every chief officer on a bulk carrier and a general cargo vessel. I believe that everybody agrees with me that you cannot become chief officer on a bulk carrier unless you demonstrate your competence in draft survey. Therefore, during the interview, you will get questions related to the draft survey and how to master the process of the draft survey. You must understand the physics behind the calculations to avoid the mistakes and to be able to defend your position in case of cargo discrepancy dispute. We need to invest our time in ourselves because basically what we do on board, we sell our time. And to sell our time for the better price on board, we need to invest in ourselves. What are we going to discuss today? The most important aspects related to the draft survey. So, what is the procedure of draft survey? What are the most common mistakes during the draft survey calculations? What is draft correction and corrected draft? What is first stream correction? And how can we determine the sign of the first stream correction? So what is basically the procedure of the draft survey? Draft survey is the method of determining the quantity of cargo loaded or discharged. And the method of draft survey is based on the Archimedes principle. A body floating freely in the water or any other liquid displaces the weight of the water equal to the weight of the body immersed in it. So theoretically, if we determine the displacement of the vessel, we can deduct the weight of the ship's hull, light ship displacement, the weight of the deductibles, and we will get the quantity of the cargo. Will it work like that or not really? Why, for the draft survey calculations, should we make the initial draft survey and final draft survey? For example, we are loading the vessel, and when we make the initial draft survey, there is no cargo on board. Then why are we supposed to make the initial draft survey? Why we cannot make only the final draft survey when there is already cargo on board? So what is the purpose of the initial draft survey? Please write down in the comments. Let's discuss this question. We need to perform the initial draft survey, even though there is no cargo on board, to determine the constant weight. And that's basically the most important aspect that requires us to make the full draft survey calculations procedure, because we cannot certainly tell what is the constant. Therefore, we should make initial and final draft survey. We perform the draft survey using the table. We start with the drafts. We take draft forward, port and starboard, mid, port and starboard, aft, port and starboard. When we take the draft readings, it is very important not to make the mistakes in the draft reading, because 1 centimeter of the mistake will give you error of 1 TPC. And by the way, one interesting question: if you, let's call it, have some disputes with the surveyor, with which draft will you stay firm? Like for the which draft you will fight the most, for the forward draft, aft draft, or mid draft? What is the most important draft for the draft survey calculations, forward, aft, or mid draft? The correct answer is mid draft, because it has the mathematical weight of 6. So forward and aft draft does not have mathematical weight in the quarter mean formula, but the mid draft is the most important one, because there is mathematical weight, there is coefficient 6 when we're calculating the quarter mean draft. So the next step, we will calculate mean draft forward, midship, and aft. It's a very simple formula. We just add forward draft port to forward draft starboard and divide by 2 to get the mean draft. We calculate trim. We calculate the trim using the following formula. It's mean draft forward minus mean draft aft. And if we have the trim by stern, I suggest to put the sign minus. If we have the trim by bow, I suggest to put the sign plus. But if you follow the just rule of the signs, for example, trim by stern is minus, trim by the head is plus, sooner or later you will make the mistake. Therefore, I suggest to put not just the sign like minus or plus. I also suggest to put the designation. For example, we have trim by stern, by aft, so I put here A, which indicates that it is trim by aft. Because to determine the signs in the draft survey, it is advisable to use the logical rules that we will discuss rather than just the rule of the signs, like minus multiplied by plus give us minus, minus multiplied by minus give us plus, because if you just follow the rule of the signs, sooner or later you will make the mistake. So we need to understand the logic behind the calculations. Then we calculate draft forward, mid, and aft corrected. What is draft corrected? Physically, what does it mean? Can you please put in the comments what is meant under draft corrected? It is the draft at the perpendicular, absolutely correct. So we use forward, mid, and aft corrections to determine the draft at the perpendiculars. So draft forward corrected, mid, and aft corrected drafts are actually the drafts at the perpendiculars. And to determine the draft at the perpendicular, we will need to know LBM, length between marks. Then we calculate trim corrected. Trim corrected is calculated as draft forward corrected minus draft aft corrected. Then we will calculate quarter mean draft. Why do we calculate quarter mean draft using such a complicated formula like forward draft corrected plus aft draft corrected plus 6 draft mid corrected and divided by 8? Why we cannot just simply add forward draft, aft draft, mid draft, and divide by 3, like to determine the average between those three drafts? Why do we need to use such complicated formula? What is the idea behind it? Can you please give the answer in the comments? I see the answer due to the longitudinal hull deflection, like sagging and hogging. That's absolutely correct. And at the end of the webinar, I will give the explanation on how the longitudinal hull deflection, like sagging or hogging, can actually influence our calculations. So we enter the hydrostatic tables with the quarter mean draft to determine TPC, LCF, moment changing trim per centimeter for the draft, which is 50 centimeters plus quarter mean draft, and moment changing trim per centimeter for the draft, which is quarter mean draft minus 50 centimeters, and we also determine displacement at sea water. At this stage, we need to know how to make the interpolation. And then the most interesting part of the calculations, we need to determine first trim correction, second trim correction, and if you have least, which is quite rare, also the least correction. And here is the point where a lot of people make very dangerous mistake. This is the sign of the first trim correction. So for example, in that case, first trim correction is minus 323 tons. And if you put the wrong sign here, instead of to deduct 323 tons, you will add 323 tons. So you will make the discrepancy in 650 tons. So the sign of the first trim correction is a very dangerous mistake. Therefore, during that webinar, we will discuss how to determine the sign of the first trim correction, not based on the mathematical rules of the signs, like plus multiplied by minus is minus, and minus multiplied by minus give us plus, but we will discuss how to determine the sign of the first trim correction based on the logical approach, based on some rules. First trim correction always has the plus sign. Then we calculate displacement corrected on trim and least. We just simply add the trim and least corrections to the displacement. We know the density of water, and we calculate the displacement corrected on the density. Then we need to determine the deductibles, which includes ballast water and all other consumables like heavy fuel, oil, MDO, lube oil, and so on. And then we will calculate total deductibles. And once we know the total deductibles, we will be able to calculate net displacement. How do we calculate net displacement? From displacement, corrected on density, we deduct total deductibles. And if we already have some cargo on board, for example, from the previous port or from the previous terminal, we also deduct this known weight of the cargo. But we mean the cargo that was loaded previously under the different bill of lading, not the cargo that we are loading exactly now and the cargo for which we are making the draft survey. So then we calculate the net displacement, and if we deduct from the net displacement for the final draft survey, if we deduct net displacement for initial draft survey, we will get the loaded cargo quantity. So let's discuss the draft corrections and corrected draft. Let's imagine that we have already determined mean draft forward, mean draft midship, and mean draft aft, and also trim. And now we need to calculate draft corrections in order to determine the drafts at the perpendiculars. Why? There is a difference between drafts and the draft scales that we actually read from the draft scales and draft at the corresponding perpendiculars. So if we have a look at our vessel, which has no trim, we can see that draft at the forward perpendicular equals to the draft at the forward draft scale. We can see the draft at the midships plane equals to the draft at the midships draft mark. And we can see that draft at the aft draft scale is the same like the draft at the aft perpendicular. And we can see that there is distance between, for example, a forward draft scale and forward perpendicular. Why do we have this distance between the perpendicular and the draft scale? Because we physically cannot put the draft scale on the perpendicular. For example, at the forward part, we have the bulbous bow, and we physically cannot put here the draft scales. So therefore, we put it at some distance from the forward perpendicular. And when the vessel has trim, for example, now the vessel is trimmed by stern, we can see that because we have the distance between the perpendicular and the draft scale, the drafts at the perpendicular and draft scales are not the same anymore. The draft at the forward perpendicular is less than draft at the forward draft scale. The draft at the aft draft scale from which we took the draft is less than draft at the aft perpendicular. And to enter the hydrostatic tables, we need to know the drafts at the perpendiculars. We need to know the corrected drafts because we should enter the hydrostatic tables with the corrected drafts. And what we have to do, we need to know the distances between the perpendiculars and the corresponding draft scales. So, for example, the distance between the forward perpendicular and the forward draft scale is 3 meters 10 centimeters. The distance between the aft perpendicular and aft draft scale is 10.48 meters. And there is also the distance between midships plane and draft scale at the middle. And we also need to know the distance between marks or length between marks, LBM. In our case, the distance between forward draft scale and aft draft scale is 171 meters and 42 centimeters. So how can we calculate the draft at the perpendicular if we know the draft at the draft scale? Because we read the draft from the draft scale. We will use quite simple geometry. So the vessel is trimmed by stern, and here is our actual water line. Here we can see the aft draft that we took from the aft draft scale. And that is the draft at the aft perpendicular. So if we know the draft at the aft draft scale, observed draft, And if we know the difference between draft at the aft perpendicular and observed draft, we can determine the draft at the aft perpendicular. So that difference between draft at the aft perpendicular and observed draft is called aft draft correction. And how can I determine that value? I know the distance between aft perpendicular and aft draft scale, and I know the vessel's trim, and I know LBM, length between marks. So what is trim? That is difference between forward draft observed and aft draft observed. I can have a look at the triangulars CAB and CDE. I can see that these triangles have the same angles. This angle is the angle of trim. Therefore, the proportion of aft draft correction to the aft draft scale distance from the aft perpendicular is the same like the proportion of trim to the LBM. And based on that, I can derive the formula of the draft correction. Draft correction equals to distance to the perpendicular multiplied by trim and divided by LBM. And if I want to calculate particularly the aft draft correction, I will use the following formula. The distance from the aft perpendicular to the aft draft scale multiplied by trim and divided by LBM. Generally, trim divided by LBM is the tangent of the angle of trim. So let's use our example to calculate aft draft correction. So the distance between the aft perpendicular and aft draft scale equals to 10.48 meters. We took that value from the stability booklet. Our trim is 2.03 meters by stern. And length between marks, we also take from this drawing from stability booklet, equals to 171 meters and 42 centimeters. Let's calculate the aft draft correction and let's put the answer in the comments. Let's share the results. So my answer is 0.1241 meters. And now we can do the same calculations for the forward draft and mid draft. The distance between the forward draft scale and forward perpendicular is 3.1 meters, and the distance between midships plane and midships draft scale is 0.84 meters. Trim is 2.03 meters and LBM 171.42 meters. So what will be the forward and mid draft corrections? Let's perform the calculations together. I have calculated the values and I can see that forward draft correction is 0.0367 and mid draft correction is 0.0099 meters. And now comes very interesting question. What will be the signs of these draft corrections? It will be plus or minus. For example, we take the trim with the minus sign if the vessel is trimmed by stern. But which sign should we use for these distances? For example, if the draft scale is located forward of the perpendicular, should this distance be taken with the plus or minus sign? If draft scale is located astern from the perpendicular, should this distance be taken with the plus or minus sign? If we follow just the rule of the signs, sooner or later we will make the mistakes. Therefore, let's put it in the logical way. So let's have a look at our vessel and with the location, with the corresponding locations of the draft scales in relation to the perpendiculars. So the vessel is trimmed by stern. Let's have a look at the forward part. Here we can see forward perpendicular and forward draft scale is located astern of the forward perpendicular. And here is the midships plane. We can see the midships plane and middle draft scale. The middle draft scale is located astern of the midships plane. And here is our aft part of the vessel. We see the aft perpendicular, and aft draft scale is located forward of the aft perpendicular. So what is draft correction? That is the difference between the draft at the perpendicular and draft at the scale. So basically, we know that draft at the scale, that is the observed draft that we actually read from the scale, and then if we add or deduct draft correction, we will get the draft at the perpendicular. So if the draft at the perpendicular is larger than draft at the scale, then observed draft, the correction will have plus sign. And if the draft at the perpendicular is less than observed draft, then correction will have minus sign. So let's have a look from the forward part. The draft at the forward perpendicular is less than draft at the forward draft scale. At the middle, the draft at the midships plane corrected draft is less than draft at the scale, observed draft. And at the stern part of the vessel, we can see that draft at the aft perpendicular is larger than observed draft, which we took from the draft scale. Therefore, the corrections will have the following signs. Aft correction will have plus sign, mid correction will have minus sign, and forward draft correction will also have the minus sign, because the draft at the forward perpendicular is less than observed draft that we took from the draft scale. And our goal is to calculate the draft at the perpendicular when we know the observed draft which we took from the draft scale. Now let's have a look at another example. We have the same locations of the draft scales in relation to the perpendiculars, but the vessel is trimmed by the bow. So we can see that draft at the forward perpendicular will be larger than observed draft. Draft at the midships plane will be larger than observed draft, and draft at the aft perpendicular will be less than the observed draft. So what will be the signs of the draft corrections? Please write down the sign of the forward draft correction in the comments. So I can see that the answers are plus. What will be the sign of the aft draft correction? Plus or minus? The sign of the aft draft correction will be minus. So forward draft correction will have plus sign, mid draft correction plus sign, and aft draft correction minus sign. And that is the way that we actually need to use in order to avoid the mistakes with the signs of the draft corrections. So we have to follow the logic, but not the simple mathematical rules like minus multiplied by minus give us plus. We see that our vessel's configuration. Our vessel is trimmed by stern, and now we can put the signs for our draft corrections. What will be the sign of the forward draft correction in our case? Please write down in the comments. So forward will have minus sign, middle draft correction will have minus sign, and aft draft correction will have plus sign. Now we can write down the draft corrections in the table with the corresponding signs. And then, in order to determine draft forward corrected, mid corrected, or aft corrected, we just need to add mean draft. We just need to add to the mean draft the correction. So for example, draft forward corrected equals to mean draft forward plus forward correction. And the correction we take with the assigned mathematical sign, minus or plus. And let's repeat one more time that corrected draft is the draft at the perpendicular. So draft forward corrected is the draft at the forward perpendicular. I can see the question why there is minus sign at the midships plane, because the draft, observed draft at the middle is larger than the draft at the midships plane, because the vessel is trimmed by stern and the draft scale is located astern of the midships plane. And now we will discuss maybe the most interesting part of the draft survey calculation process. What is first trim correction? Probably you heard that first trim correction appears due to the longitudinal distance of the center of flotation from the midships plane and vessel's trim. It is also called the correction for LCF or the correction for layer. So when we know the quarter mean draft, and once we entered the hydrostatic tables to determine TPC, LCF, displacement at seawater, and so on, we need to calculate the trim correction. But we need to understand the origin of the first trim correction. Why is it called the correction for LCF or the correction for layer? First of all, we need to determine what is LCF. LCF is longitudinal center of flotation. But what is center of flotation? Please write the answer in the comments. Let's discuss what is center of flotation. I can see the question, what is keel correction? Let me shortly explain what is keel correction. When naval architects are designing the vessel, they use the dimensions which are called molded dimensions. For example, you heard width molded, draft molded, depth molded. What does it mean by the word molded? It means that the measurement is taken from the internal surface of the shell plating to the internal surface of the shell plating. But the shell plating has the thickness itself. And therefore, the extreme measurement, for example, extreme width, extreme depth, and also extreme draft, is measured from the outer surface of the shell plating to the outer surface of the shell plating. And the draft scales are calculated or marked on board from the outer surface of the shell plating, from the outer surface of the vessel's keel. But some hydrostatic tables should be entered with the draft molded, which is taken not from the outer surface of the keel plating, but from the inner surface of the keel plating. Therefore, if stability booklet requests we should deduct from the extreme draft, which we took from the draft scale, we should deduct the keel plate thickness to get molded draft and to enter the hydrostatic tables. So let's discuss what is the center of flotation. Let's imagine that we have our vessel, and I would like to tell at the beginning that center of flotation is the geometric center of the ship's waterplane area. And the main feature of the center of flotation is that the vessel rotates around center of flotation when it changes its trim. So our vessel is submerged into the water and we have the water line. Let's remove the part of the vessel which is above the water. We are not interested in this part. We will remove it. And then we will have a look at the vessel, what is remaining. We will have a look from the top. And what we will see is called the waterplane area. This is the waterplane area. And any area has its geometrical center. So the geometrical center of the water plane area is called the center of flotation. The idea behind the center of flotation is that the vessel changes its stream, uh, that the vessel rotates around center of flotation when the vessel changes its stream. So it looks in the following way. Why does the vessel rotate around center of flotation when it changes its stream? If we do not change the displacement of the vessel, but change only the trim, for example, we transfer some cargo from the forward part to the aft part of the vessel, the displacement remains the same. Therefore, due to the change of the trim, the amount of underwater part of the vessel which went out from the water should be the same with the displacement of the part of the vessel hull which entered the water. So we changed the trim. These parts of the vessel's hull which went out from the water should be equal to the volume of the vessel's hull which entered the water. And this equation works when the vessel rotates exactly around the center of flotation. And let's imagine that we change the vessel's draft. And what will happen to the center of flotation? Will center of flotation change its position? Yes, center of flotation will change its position because when we change the vessel's draft, the geometrical shape of the water plane area also changes. And if it changes, the center of flotation moves to another position because we have the different water plane area now. And what is LCF? That is longitudinal center of flotation. That is the longitudinal distance from the either aft perpendicular to the center of flotation or from the midships plane to the center of flotation. There are two longitudinal coordinates systems. The first is when the zero starts from the aft perpendicular. So LCF is calculated as the distance from the aft perpendicular to the center of flotation. And this coordinate will be called LCA because it stands for longitudinal center of flotation from aft perpendicular. Therefore, if in the hydrostatic tables you see LCA instead of LCF, and you can see that this LCA value is similar to the half of the vessel's LBP, it means that this coordinate is measured from the aft perpendicular. But for the draft survey calculation process for the first stream correction, we should take the value of LCF measured from the midships plane. If we have LCA instead of LCF in the hydrostatic tables, we will need to calculate the LCF value. It's easy to calculate the LCF value if we know the LCA value. We just need to deduct from the LCA value the half of the vessel's LBP. If the vessel would be of the rectangular shape, like if our vessel was like the regular barge, when we will change the vessel's trim, the vessel would be rotating around center of flotation, which would locate that midships plane area. So now let's explain what is first trim correction. If our vessel had the shape of the barge, which has, let's call it rectangular shape, center of flotation would be located at the midships plane. And we would be changing the trim of our barge. We can see that center of flotation coincides with the midships plane, and the barge rotates around this point. So when we change the trim, the volume which went out from the water equals to the volume which entered the water. But the vessel has different shape, and therefore center of flotation does not coincide with the midships plane. It is not located at the midships plane. There is distance between midships plane and the center of flotation. So the vessel rotates around the center of flotation to be sure that the volume which went out from the water equals to the volume which entered the water. And as we can see, due to the rotation around center of flotation, there is difference between draft measured at the center of flotation and draft measured at the midships plane. The draft measured at the midships plane is called quarter mean draft. This is the draft that we determine it using the formula forward draft corrected plus aft draft corrected plus 6 mid draft corrected and divided by 8. And we thought that quarter mean draft is the most accurate draft in the world that we had to use to enter the hydrostatic tables, and we actually used this quarter mean draft to enter the hydrostatic tables to determine the TPC value, LCF value, MCTC value, and displacement at sea water. But it ended up that the most accurate draft that we had to use to enter the hydrostatic tables is not the quarter mean draft that is, let's say, taking at the midships plane, but the most accurate draft is true mean draft, which is measured at the center of flotation. And what should we do now? Should we determine true mean draft, which is measured at the center of flotation, and then enter the hydrostatic tables again to determine TPC value, LCF, and so on? And of course, displacement at sea water. That will be very complicated. Therefore, we will follow the another way. We will calculate the difference between true mean draft and quarter mean draft. True mean draft is the most accurate draft which we had to use. And this is the draft measured at the center of flotation. And quarter mean draft is the draft at the midships plane. And we need to find the difference between those two drafts. And that difference between those two drafts is called the layer correction. And the first stream correction is the correction for layer, exactly for this difference between the quarter mean draft and true mean draft. The formula of the first stream correction is the following. First stream correction equals to LCF, to midships, not from the aft perpendicular, but from the midships, multiplied by trim corrected, multiplied by TPC, multiplied by 100, and divided by LBP. This formula looks a little bit complicated, but I suggest to derive that formula by ourselves to understand how it works. So we need to calculate the value of the layer correction. That is the difference between the true mean draft, which is taken from the center of flotation position, and quarter mean draft, which is basically the draft at the midships plane. So we know the LCF value, and we know the tangent of the angle of trim. We already met this formula. Tangent of the angle of trim equals to trim corrected divided by LBP. So using the simple trigonometry, we can find out that layer correction equals to LCF multiplied by tangents of the angle of trim. So LCF multiplied by trim corrected and divided by LBP. So we have determined the formula that we will use to calculate layer correction. Layer correction is the difference between true mean draft and quarter mean draft. But once we found the layer correction, what should we do next? We determined the difference between these two drafts. And we don't want to enter the hydrostatic tables again to determine the displacement, make interpolations. We want to follow more simple way. And to follow a more simple way, we will just multiply the layer correction by TPC, tons per centimeter, and we will get the first trim correction. And then we will just add that first trim correction to the displacement that we took from the hydrostatic tables, and we will get the displacement corrected on that difference between quarter mean draft and true mean draft, which we would have to take from the center of flotation position, but we physically did not have chance to do it. And now there is a question. Why do we have 100 in this formula? Why layer correction is not simply multiplied by TPC, but it is first multiplied by 100 and only then by TPC? Please put the answer in the comments. We can see the formula of the layer correction. So LCF is measured in meters, trim corrected measured in meters, LBP measured in meters. So layer correction initially is measured in meters, but in order to multiply it by TPC, we need to convert layer correction into centimeters. So meters we need to convert in centimeters. Therefore, we multiply layer correction by 100 in order to convert meters in centimeters to be able to multiply layer correction measured in centimeters by TPC. And now, if instead of the layer correction, we put its formula, LCF multiplied by trim corrected and divided by LBP, so this is the left part of the formula, we will get the formula of the first trim correction. So first trim correction equals to LCF multiplied by trim corrected divided by LBP and multiplied by TPC and multiplied by 100. We have derived the formula of the first trim correction. And we can perform the calculations using that formula. So for example, for initial draft survey, first trim correction would be equal to LCF. In our case, center of flotation is located forward of the midships plane. Therefore, we put here designation forward and sign multiplied by trim corrected. We have trim by stern, so we took it with the minus sign. And we also put the designation A for stern. We multiply by TPC, 53.2 metric tons. We multiply by 100, and we divide by the length between perpendiculars, 185 meters. We get first trim correction minus 323.633 metric tons. And the same calculations we will make for the final draft survey. Please perform the calculations for the final draft survey and let's share the results. Let's compare the results. Correct. TPC is measured as tons per centimeter, but we convert layer correction from meters into centimeters because in formula we multiply by 100 to convert layer correction from meters into centimeters to be able to multiply that value by TPC. So the answer is plus 83.541 metric tons. And as we can see, the values of the first trim correction are quite large. For initial, it's minus 323 tons. For final, it's plus 83 tons. So we can understand that if we make the mistake with the sign, for example, instead of minus, we put plus, or instead of plus, we put minus, we will make big discrepancy in the calculations, and we cannot afford such a mistake. Therefore, I would like to suggest the options how to determine the sign of the first trim correction, not based on the mathematical rules, like minus multiplied by minus give us plus, but based on the logic which is used by senior draft surveyors. So first of all, I would like to tell you that if trim and LCF has the same designations, then the first trim correction will have the sign plus. What does it mean? For example, trim by aft and LCF is located aft of the midships plane. So same designation. In our table, we would have trim aft and LCF aft. So they have the same designations, and therefore first trim correction has plus. If trim and LCF have different designations, for example, trim by aft, but LCF is located forward of the midships plane. So trim A aft and LCF F forward. Then the first trim correction will have the minus sign. How to remember that? The vessel is trimmed by aft. Center of flotation is located aft of the midships plane. So center of flotation is located in the same direction with the trim. Trim and center of flotation are friends. Friendship is good, so the first trim correction has plus sign. Vessel is trimmed by aft, but center of flotation is located in the opposite direction. Center of flotation is located forward of the midships plane. So center of flotation and trim are located in the opposite directions. So they are enemies. It's bad, therefore first trim correction has minus sign. And another option, the vessel is trimmed by the bow. Center of flotation is located forward of the midships plane, and vessel has forward trim. So they are friends. Friendship is good. First trim correction has plus sign. Vessel has trim by forward, but the center of flotation is located aft of the midships plane. They are located in the different directions. They are enemies, and it's bad. So first trim correction has minus sign. That is the rule how to remember the signs of the first trim correction, not to make the mistake which can cost a lot. And also we can determine the sign of the first trim correction visually based on the sign of the layer correction. The sign of the first trim correction fully depends on the sign of the layer correction. So, for example, what is the idea of the layer correction? The idea of the layer correction is to determine true mean draft when we know quarter mean draft. If the draft at the middle, quarter mean draft, is larger than draft at the center of flotation, is larger than true mean draft, then layer correction will have minus sign. We know true mean draft, we need to deduct layer correction to get true mean draft. Layer correction has minus sign, so first trim correction will also have minus sign. Another option, we can see that true mean draft is larger than quarter mean draft at the middle. In that case, layer correction will have plus sign. And we can see in that example that true mean draft is less than draft at the middle, is less than quarter mean draft. So in that case, layer correction will have minus sign. And in that case, we can see that true mean draft is larger than quarter mean draft. And in that case, layer correction will have plus sign because we will need to add quarter mean draft to layer correction to get that true mean draft. So that is the way how we determine the signs of the first trim correction. And the sign of the second trim correction will always be plus. And what is second trim correction? Second trim correction corrects the first trim correction. When we enter the hydrostatic tables, we get the values for the zero trim condition. But the vessel actually has some trim, and therefore the actual position of the center of flotation is actually slightly different from the value which we took from the hydrostatic tables, because we took this value for the zero trim condition. And second trim correction makes this correction for the position of center of flotation, because as we know, center of flotation is not located at the same point. It moves, depends on the shape of the water plane area. We have discussed the most interesting and I would say probably the most important points of the draft survey calculations. And I can see the question regarding the sign of the LCF. Is it obtained from the hydrostatic table? Okay, so the sign of the LCF, it is indicated in the hydrostatic tables, but there is a problem. In some tables, if center of flotation is located forward of the midships plane, it has plus sign. In some tables, it may have minus sign, and it may confuse us during the calculations. Therefore, as I have mentioned, using just the simple rule of mathematical signs, like plus multiplied by minus give us minus, can sooner or later bring us to the mistake. To avoid the mistakes, we need to understand if the vessel is trimmed by bow or stern, by forward or aft, and whether the center of flotation is located ahead of the midships plane or astern of the midships plane. I would like to offer to participate in my advanced draft survey course and to get my book in PDF format about the draft survey, complete guide on draft survey. With this course, we will understand what influences the draft survey accuracy, how to improve it. We will learn how to avoid common calculation mistakes, and we will also identify the tricks used by surveyors and how to counter to these tricks. At the first module, we will discuss the fundamentals of the draft survey. We will get the systematic understanding of the draft survey procedure. That's very important because if you know the physics, the basic understanding of this process, you will avoid the mistakes. Draft readings, it looks to be quite easy how to read the drafts, but it's not so easy when we experience some swell, some waves. We will discuss which methods to use to determine the drafts with the high accuracy when the vessel experiencing swell and some waves. It's very important to read the drafts correctly during the draft survey calculations process, because if you make the mistake with the draft readings by 2 centimeters plus for initial draft survey and 2 centimeters but minus for final draft survey, the total mistake will be 4 centimeters. And 4 centimeters multiplied by TPC of 50 tons, that give us 200 metric tons. That's a lot. And the third module is sampling of the water density, how to do it correctly according to the procedure. Module number 4, cargo quantity calculations. We will discuss the full calculations process with the very clear explanations of the physics of the process. Like we discussed the physics behind the first trim correction. We don't just give the formula, because if you read this formula today, it does not guarantee that you will remember this formula tomorrow. But if you understand how that formula works, that's the guarantee that you will remember this formula forever, because you understand how it physically works. Module 5 about deductibles. We will discuss how to calculate the quantity of the ballast, even if you don't have the sounding tables, the methods that are used by the senior surveyors. What is imaginary sounding, what is trim correction for sounding, for slack condition, for wedge condition. Module 6, how to determine net displacement. Module 7, cargo weight and constant calculations. This is the final step of the draft survey, how to determine constant of the vessel and how to determine the cargo weight. And module 8, factors that may influence draft survey accuracy. For example, you come on board and you see that you have, let's say, some difference in the constant. So probably you perform the draft survey with the different accuracy. We will discuss which factors do actually influence that accuracy. And module 9, discrepancy in the cargo weight. What to do in case if you have the discrepancy? Which letter of protest should be prepared and how it should be written, and which letters, which documents you should not sign in order to protect the interests of your principal. As I have mentioned, this course was already attended by more than 1,000 our colleagues. We have been conducting this course already for 6 years for Ukrainian seafarers in Russian language, and now we have translated it in English language to share it with the participants from all over the world. We are seafarers and we are colleagues all over the world. Therefore, we have translated all our courses in English to share it with everybody, no matter what country we come from, what flag the vessel sails, or what company we work for. Life at sea makes us part of the same professional community. We share the same challenges, responsibilities, and we have the same respect to the sea, and we rely on each other's knowledge and professionalism. So here are some feedbacks from the participants of the draft survey course. Who is this course for? This course is definitely for second officers who would like to gain clear, structured knowledge of the draft survey procedure, and of course to get the promotion, pass interview successfully, and then to work in the chief mate's position. And of course, this course for chief officers and captains who would like to learn the draft survey at the level of the senior draft surveyor to avoid the mistakes and to know how to act in case of the disputes. All lessons will be available forever. So you have the lifetime access to the recordings and you can review them anytime. The value of these 9 modules is $90. So the total course value, $90. And you will also get the exclusive bonus. This is complete guide on draft survey. This is my book that you can use as the quick reference guide in case if you have some question about the draft survey calculation procedure, in case if you have some dispute with the draft surveyor, you can always refer to my book, Complete Guide on the Draft Survey. So you get not only the course, but you also get the complete guide on the draft survey. And also after the course, you may pass the post-course test to check your knowledge. And if you have passed the test successfully, you get the certificate of attendance that you participated in the advanced draft survey course, you passed the test successfully, and you get the attendance certificate from Marine Club. In summary, you get 9 modules of the advanced draft survey course, which fully explains the procedure of the draft survey, including the practical aspects. And of course, you get nice bonuses like my book, Complete Guide on Draft Survey, and also, if you pass the test successfully, attendance certificate. The participants of the online webinars always get the best offers. Therefore, for those who participate today in the online draft survey webinar, we offer 55% discount, which works until tomorrow, until 23:59. And instead of $90, we offer you to participate in the course for just $39. You can see the button participate. If you press this button, you will get the next page where you need to leave your name and phone number. Also, please select which messenger can you use on this phone number, whether it is Viber or WhatsApp, and also please put your email address. And the manager of Marine Learning Club will contact you within 24 hours to provide the full explanation on how to participate in the Advanced Draft Survey course. You can also pay today. You just press the button Pay Here, and using the safe payment method, you can start participation in the Advanced Draft Survey course just for $39. And I would like to remind you that you will have the lifetime access to the recordings. And remember that you risk nothing with us. Our courses were attended by more than 10,000 our colleagues. And if you don't like the educational material, if you don't like the way it's presented, or anything else, you just write to us and we will make the refund of your money with no questions asked. Now we basically have two options. Option number one is to rely on the chance that some chief officer will explain how to perform the draft survey, or we can find more correct way to prepare yourself when you are ashore for the next contract, to learn the draft survey procedure, to demonstrate that you know the draft survey procedure, and to get the promotion for the next rank. So in summary, what is Advanced Draft Survey course? This is 9 modules and exclusive bonuses just for the $39. And now we can start our questions and answers session. Please ask your questions about the draft survey or about any aspects of the chief officer's job, and I will answer on your questions. It might be also questions related to the captain's job or a navigational officer job. But of course, mostly let's concentrate on the questions related to the draft survey. Should we use corrected drafts for the ballast calculations? For the ballast calculations, we need to use trim corrected. And to determine trim corrected, we need to know the corrected drafts. Draft forward corrected and draft aft corrected. In the hydrostatic table, how can we know if details is in molded depths? Before the hydrostatic tables, there are explanations of the abbreviations. And for example, there will be like T and M close to the T. So that means draft molded. So that will be explained whether these hydrostatic tables are used for the draft molded or for the draft extreme, or in the hydrostatic tables could be two columns, one with the draft molded, the other one is with the draft extreme. And we should apply keel thickness correction only if it is stated in the stability booklet. If it is not stated, we just take the draft from the corresponding draft scale and we enter the hydrostatic tables without applying of the keel thickness correction. Will we have training for the trimming step? Could you please give more details about this training? What is the plan after these lectures? Will there be available PDF to aid the process of the course? Yes, correct. My electronic complete guide on draft survey will remain with you. When we take shoreside drafts and seaside drafts not possible, then how to manage it to calculate my water tube? We discussed this question on the draft survey course because it's quite this is the topic that we need to demonstrate visually. So in the draft survey course, we demonstrate it visually. Trimming step, the final step to know how many tons needed to complete our cargo weight, how to distribute the cargo correctly to be at the correct trim. We have the special tool, which is called trimming tool, which is used to perform these calculations. The best option is to use the program. The trimming tool to perform these calculations to distribute the cargo at the final stage correctly. Is the electronic draft survey need to load the hydrostatic table? Depends which program you use. When entering drafts to hydrostatic table, why in general are they using trim zero tables? Because if you use the trim tables, hydrostatic tables for trim not zero, but for example, for actual trim, like 1 meter by stern, half meter by stern, and then following the draft survey calculation process, you apply first trim correction and second trim correction, you will apply these corrections 2 times. So that will be the mistake. What is the accreditation for the certificate? It is the certificate of the attendance. So there are no, let's say, accreditation organizations which give you the accreditation or like license for the performance of the draft surveys. So this is the certificate just of the attendance of this training. What will be the next schedule for the advanced draft survey course? You can attend this course at any time, but the discount is offered only if you participate in the online webinar. So to reserve the place with the best offer, with the discount, you need to press the button participate and leave your phone number and name so that Marine Learning Club manager could contact you and offer you to participate in the course based on the best terms. How is the amount of cargo determined in each cargo hold? Opens some other page. You cannot determine exactly the cargo weight in every single hold if you perform the simultaneous loading of the different cargo holds using the draft survey. Draft survey is used only to determine the total cargo weight loaded or discharged. So to determine the cargo weight in each cargo hold, you need to determine more or less the volume of the cargo in the hold and then multiply this volume by density or divide by stowage factor. And how will we reach the courses after the purchase? Marine Learning Club manager will contact you within 24 hours and provide the full information. The course will be available at the Marine Learning Club platform, and you will be able to participate at any time you like. So thank you for your time and thank you for your attention. I hope that this webinar was useful for you. I hope that you gained the useful knowledge about the draft survey calculation procedure. This knowledge is required for the safe work on board the vessel in the chief officer's capacity. My name is Captain Artur Sokolov, and we are Marine Learning Club. See you next time. Wish you safe seas. Bye-bye.